And then we of course also have arrays in Solidity. This is a reference type that holds elements in a sequential list. Each element can be accessed using the correct index. And indices in arrays for programming always start with 0. So here with an array of 5 elements, you can access each element with the index either 0, 1, 2, 3, or for the last element you'd use index 4. Arrays in Solidity work mostly as in other languages. You can either define an array as fixed size or as dynamic size. So here we define a state variables as arrays. In the first case, it's a dynamically sized array without any initial values. Here we have a dynamically sized array, but with some initial values. And here we have a fixed size array where you enter the size of the array in the brackets when you declare the array. And this array here cannot be resized anymore because it's fixed size. And then you also can have arrays in memory. You can declare new memory arrays with the new keyword, or you can directly declare them with values. But note that memories arrays actually can never be resized, even if you don't declare them as fixed size as we did here. And of course you can also have nested arrays, either in state or in memory, and either dynamic or fixed, or even mixed, fixed and dynamic. When you declare a state array as public, Solidity auto-generates a view function for us. This is similar to what it also did for public state mapping types. It auto-generates a view function where it expects the index of the array as input and returns the element at the position of the passed index argument. If instead you want to have a view function that returns the whole array, well, that's also possible, but you just have to declare it yourself like this. So we just return the array directly. You have 3 additional members on array types. First, you can just get the length of any array by using .length. And if your array is in the state and dynamically sized, you can also use push and pop. With push, you can append a new element to the end of the array, and with pop, you can delete the last element. And we've actually used arrays before because we've used the special bytes and string types, which are actually just arrays. The bytes type is similar to a bytes1 array, but it's just more gas efficient. And string is just like bytes, but it does not allow for the length or index access. So now we could, for example, push all the winners of our lottery onto an address state array using push. This is very simple, but ask yourself, why do you want to store this in an array? Because remember, mappings are kings. If you don't have a good reason for storing it in an array, maybe it's better to just store it in a mapping from address to Boolean and set it to true for all winners. But, maybe you want to iterate over the winner array. In this case, the issue is our array here can grow infinitely, and then iterating over it becomes impossible, at least in a single call. So then maybe you just want to store only the last 3 winners for whatever reason. Here we again have our winners address array, and we push the winner to this array. But now we check if the array now has more than 3 elements. If it does, we copy over every single element one by one and then delete the last one using pop. And yeah, this is very inefficient. And if it's only 3 elements, then it's still okay. But if you were to use large arrays, well, then you need to find a different solution. So if you want to delete one element in an array, one solution can be to just copy the currently last element to that position, essentially overriding the element we want to delete. And now the last element is in the array twice, obviously, so we just call pop to remove the last element. And of course, if you care about the order, then this doesn't work anymore because it will change the order in the array. But it's very efficient. So then, if you care about the order, you might want to use more advanced data structures like linked lists. Those are not built into Solidity, so you'll have to develop them yourself or find a reference implementation online. But again, maybe you should just use mappings to begin with.